Okay. Operations with fractions. Add and subtraction. Okay. Parts of a fraction. There are two parts to a fraction, the top and the bottom. On the bottom of a fraction is the total number of parts that equal a whole. So in this picture, we have a cake. There are 4 pieces. A 4 would go on the bottom because 4 is the total number of parts that would equal a whole. Now, the top is the number of parts. So in this picture, we are missing 1 piece of cake. So we have 3 pieces. So you put a 3 at the top because you have 3 pieces out of 4. The top number in a fraction is called the numerator. Numerator. And the bottom number, the denominator. So the denominator is the total number of parts that equal a whole. In this cake, it is 4. And the numerator is the number of parts. In this picture, we have 3. We have 3 pieces of cake out of 4. Reading and writing fractions. In this picture of the circle, we have 1/4. You can see 1 piece out of 4 possible pieces. We can say this 1/4 or 1/4. So this piece is 1/4 of the circle or 1/4 of the circle. Below it we have 1/2. 1/2 of the circle. The top right we have 3/4. We have 3 pieces out of 4 and we say that 3/4. And on the bottom we have 1 1/2. 1 and 1/2. 1 1/2. What fraction of the balls are purple? Well, the first thing we do is we count how many parts there are. 1, 2, 3, 4, 5, 6. So the denominator is 6. What fraction of the balls are purple? Well, there's only 1 purple ball. So the numerator is 1. 1/6 or 1/6. What fraction of the musical instruments have strings? The first thing we do is count how many musical instruments we have. 1, 2, 3, 4, 5. The denominator is 5. We have 5 instruments. And then it says, what fraction of the musical instruments have strings? So we count how many of these instruments have strings. Does this have strings? No, a trumpet does not have strings. A violin does have strings, so we know 1. A harp has strings, so we have 2. A saxophone does not have strings, and a tuba does not have strings. So we have 2/5. 2 out of 5. So 2 is the numerator, 5 is the denominator. What fraction of the arrows hit the bullseye? First thing we do, count the arrows. There are 3 arrows, so our denominator is 3. What fraction of the arrows hit the bullseye? Well, only 1 hit the bullseye, so 1 out of 3, 1/3. What fraction of the pins are knocked down? First thing we do is find the denominator. So we count how many pins there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pins. How many have been knocked down? 1, 2, 3. The numerator is 3. There are 3 knockdown pins. The denominator is 10. There are 10 pins total. 3 out of 10 pins have been knocked down. 3/10. Okay, equivalent fractions. Name the same amount but have different numerators and denominators. These pizzas show us what we mean. In both pizzas, the same amount of the pizza is being marked. In pizza 1, it's 1/2. A line is drawn down the center, and we are talking about 1/2 of the pizza. In pizza 2, we have 2 of the quarters marked. So we write it 2 out of 4. There are 4 possible quarters. We have 2 of them marked. These are equivalent fractions. They equal the same thing. 1/2 equals 2/4. Okay, now we just saw that this pizza is 1/2, which equals 2/4 in this pizza. In the third pizza, what is an equivalent fraction? The first thing you're going to do is count for the denominator, count how many pieces are total, and then you count for the numerator. How many would equal half of the pizza? Go ahead and type me your answers when you think you have it correct. I'm waiting for the answers. Yes! Correct! We have our first correct answer. It is 8 pieces total, and half of the pizza. You look right down this middle line. There are 1, 2, 3, 4 pieces. 4 pieces would make half of the pizza, so the correct answer is 4/8. I'm going to try to use this pencil again. It may not work well, but we will see. 4/8 is correct, because there are 1, 2, 3, 5, 6, 7, 8 pieces total, but we're just looking for what's on the other side of this line. So we have 1, 2, 3, 4 pieces. 4/8. Here's another way for us to see this. If we're looking at the orange pieces, we have 1 out of 2 pieces equals 1, 2, 2 out of 4 pieces equals 3 out of 6 pieces. They're equivalent fractions. They mean the same thing. They are the exact same picture, just divided differently. So in this picture, we only have 1 orange and 1 red. In the second picture, they cut them in half. So we have 4 pieces total, so the denominator is a 4, and 2 are now orange. In this picture, they cut it again, and we now have 3 red, 3 orange. So our denominator is 6. There are 6 total pieces, and we have 3 that are orange. Okay, to find equivalent fractions, multiply the numerator and the denominator by the same number. So, if we wanted to find what equivalent fractions there are for 1/3, 1/3, multiply the numerator and the denominator by the same number. So in this example, 1/3 times 3 times 3 equals 3/9. You could also do 1/3 times 4 times 4 equals 4 over 12. As long as you're multiplying the numerator and the denominator by the same number, you will have an equivalent fraction. So 1/3, 3/9, 4/12 are all equivalent fractions. You can also divide the numerator and the denominator by the same number. So in 4 over 12, divided by 4, that equals 1/3. So 4/12 and 1/3 are equivalent fractions. If we had the fraction, let's take 3/9 again. In equivalent fraction, you divide the top and the bottom by 3. You get 3 divided by 3 is 1. 9 divided by 3 is 3. An equivalent fraction for 3/9 is 1/3. Now, adding like denominators. You only add the numerator. You pull the denominator over, and you only add the numerator. So, in this picture, you have 1/4, and then you are adding 3/4. The answer is 4 over 4. Simplify your answer. 4 over 4 is 1. The reason is because if you have the same denominator, that means that both fractions are talking about the same amount of a thing. They're both talking about 4 pieces. So you pull that 4 all the way over to the answer. 1 out of 4 plus 3 out of 4 equals 4 out of 4. If it was out of 6, 1 out of 6 plus 4 out of 6 equals, let me make this 6 a little clearer. Oh, that did not help. You pull the 6 over because you are still talking about 6 things, and you add the numerators. So 1 plus 4, correct, 5/6. Now, adding fractions. Adding like denominators again. Here are more examples. On this top one, there are 5 pieces. 3 of them are green. We have 3 over 5. 3/5. Plus 1 over 5 for the blue one. 1 over 5. You keep the denominator the same. You only add the numerators. So 3 over 5 plus 1 over 5 equals 4 over 5. In this second example, we have 6 pieces. 2 over 6, that's how many are green. 2 over 6, how many are blue? Add them. The 6 stays the same. You add the 2. You add the numerators, so 2 plus 2 is 4. Simplify your answer. We want the simplest number, so we want to make sure that both of these numbers cannot be divided by the same number to get a smaller equivalent fraction. 4 over 6. Both the numerator and the denominator can be divided by 2. Which means we have 2 out of 3, 2/3. Now, in the fraction that we had earlier, 4 out of 12. If I want that simplified, what would it equal? Type me the answer if you know what the simplified version of 4 over 12 is. 1 over 3. Correct. You can divide the top and the bottom by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So the simplified version of 4 over 12 is 1 over 3. Now, we're still adding with like denominators. We have 5 over 12 plus 3 over 12 equals 8 over 12. We're keeping the denominator the same. If they are like fractions and they have the same denominator, then we do not change the denominator. We keep it the same and we only add the numerator. So 5 over 12 plus 3 over 12, we carry the 12 over and we add the numerators. That equals 8 over 12. Simplify your answer. So 8 over 12 can both, the top, the numerator, and the denominator can both be divided by 4. Simplifies to 2 over 3. In number 2, we have 1 over 10 plus 3 over 10. 1 plus 3 is 4. We carry the denominator over. We have 4 over 10. Simplify your answer. Both can be divided by 2. The answer becomes 2 over 5. Now we have a mixed number. 4 and 4/9 plus 3/9. We bring the 4 over. We keep the 9 the same. Add the numerators. 4 and 7/9. That is as simple as it will get. 4 and 7/9 does not reduce. Now 5 and 3/8 plus 1/8. Carry the 5 over, so it's 5. We know it's going to be over 8 because we keep the denominator the same. Add the numerators. 3 plus 1 is 4. 5 and 4/8, but we want it simplified. 5 and 4/8, we're not going to change the whole number, only the fraction. So we divide it by 4 over 4, and we get 5 and 1/2. Are there any questions? No. Okay, we will continue. Subtracting. Okay, subtracting fractions with like denominators. As we did in addition, you only subtract the numerator. So 4 over 4 minus 1 over 4 equals 3 over 4. You keep the denominator the same, you just subtract the top. 4 over 5 minus 1 over 5. Keeping the numerator the same, we're keeping the denominator the same, we are subtracting the numerator. 4 minus 1 is 3. Pull the 5 over, 3 out of 5. 3/5. Okay. Here are more examples. 5/6 minus 2/6. You keep the denominator the same. You subtract the top. 5 minus 2 is 3. Simplify the answer. Both can be divided by 3. So 1/2 is the correct answer. 5 over 12 minus 3 over 12. You keep the denominator the same. Subtract the numerator. The answer is 2 over 12. Simplify the answer. Both can be divided by 2. The final answer is 1 over 6. With a mixed number, 4 and 4/9 minus 3/9. you carry the whole number over, keep the 4, and subtract the fractions. 4 over 9 minus 3 over 9 equals 1 over 9. 4 and 1/9 is the answer. It is the simplest form. It cannot be simplified. Now, subtracting two mixed numbers. First, subtract the whole numbers. So we have 4 minus 3 equals 1. Now subtract the fractions. We have 8 over 9 minus 2 over 9. 8 over 9 minus 2 over 9. 8 minus 2 is 6. We keep the denominator the same. We remember that the whole numbers were 4 minus 3 equals 1. So we know it's 1 and 6/9. But it can be reduced. Simplify the answer. 6 over 9 can both be divided by 3, both the 6 and the 9. The final answer is 1 and 2/3. Now, when you are adding and subtracting and you do not have the same denominator, you have to find the least common multiple, which is the least common denominator. The smallest common multiple of a set of 2 or more numbers is the least common multiple. So right here we have the example 5 and 6. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. We're looking for the two numbers that are the same. 30 is the least common multiple because 30 is the smallest number that both 5 and 6 can be multiplied by to equal. A shortcut for finding the least common denominator or least common multiple is to check and see if the smaller denominator divides evenly into the larger denominator. If it does, use the larger denominator for your least common denominator or least common multiple. In the example, 1 over 3 plus 1 over 9. 3 will divide into 9 evenly, so the least common denominator is 9. All you have to do is make 1 over 3 an equivalent fraction with the denominator 9. I hope we do that on the next page. Okay, we're going to do this example. So, if we know that 9 is the least common denominator, then we know that the equation is going to be 1 over 3 plus 1 over 9, but the denominators are going to be a 9. So 3 times what equals 9? Type me an answer. What can we multiply 3 by to make it 9? Three. We can multiply 3 by 3. To make the denominator of 1/3 equal 9, we need to multiply it, the numerator and the denominator, by the same number. So we know that the denominator needs to be 9. 3 times 3 equals 9. When we multiply the top by 3, we have 3/9. So 3 over 9 plus 1 over 9 equals 4 over 9. Here we have more examples. 1 over 5 plus 1 over 10. 5 can divide evenly into 10. So we know that the least common denominator is 10. 5 equals 5 times 1 is 5. 5 times 2 is 10. So we're going to multiply the numerator by 2 and the denominator by 2 to make it 2 over 10. 1 over 10 is already with a denominator of 10, so we don't need to multiply it. We now have 2 over 10 plus 1 over 10 equals 3 over 10. Do we understand? Okay, so for number 1, if we want to add 1/2 and 1 over 8, again, 8 is the least common denominator because 8 can be divided by 2 evenly. So all we do is we have to make 1/2 into an equivalent fraction with a denominator of 8. 1 times 4 over 2 times 4 becomes 4 over 8 plus 1 over 8. The final answer is 5 over 8. Now number 2. 2 over 5 plus 1 over 3. Neither of those are not, 5 cannot be divided by 3 and 3 cannot be divided by 5. So we have to find a least common denominator. But we know that 5 times 3 equals 15 and 3 times 5 equals 15. So our least common denominator is 15. We multiply the numerator and the denominator of 2 over 5 by 3 so we can have a fraction with a denominator of 15, and we get 6 over 15. We add it with 1 over 3, multiply the numerator and the denominator both by 5. We have 5 over 15. Add them together. Keep the denominator the same. Add the numerators, and we have 11 over 15 as the final answer. Here we have more examples. 4 over 5, 4/5, plus 2/3, 2 over 3. We need to find the least common denominator of 5 and 3. Again, it's 15. We just did it on the last one. 4 over 5 times 3 for the numerator and 3 for the denominator gives us 12 over 15. 2 over 3, multiply 5 by the numerator and 5 by the denominator, gives us 10 over 15. We add those together, keeping the denominator the same, adding the numerators. We have 22 over 15. This is an improper fraction. We want the answer simplified as a mixed number. So all we do is do the division. 22 divided by 15. 20 divided by 15, it goes in once. You subtract 15 equals 7. The remainder is 7 over 15. The final answer is 1 and 7 over 15. In example 2, or number 4 actually, we have a mixed number, 2 1/4, plus 1 over 6. Now we need to make 2 1/4 into an improper fraction. So what we do is we multiply the denominator by the whole number, and then we add add the numerator. So 4 multiplied by 2 is 8, plus the numerator, which is 1, gives us 9 over 4, plus 1 over 6. We need the least common denominator, which for 4 and 6 is 12. 9 over 4, 4 has to become a 12. Multiply the numerator and the denominator by 3, and we have 27 over 12. For 1 over 6, to make 6 into the common denominator of 12, we have to multiply it by 2. So multiply the numerator by 2 and the denominator by 2, and we get 2 over 12. Now 27 plus 2 is 29, with the denominator of 12. Now, that's a 2 right there. Now, we don't want an improper fraction, we want a mixed number. So again, we divide 29 by 12. It goes in 2 times, 24, the remainder of 5. So 2 and 5/12 is our answer. That is the simplest form. Okay, for number 5, we have now subtraction. So 1 over 2 minus 1 over 8. For the least common denominator, we know that 8 can be divided by 2 evenly. So 8 is our least common denominator. So we have 1 over 2 multiplied by 4 so that we can have the denominators of 8. Numerator times 4 is 4. Denominator times 4 is 8. 4/8 minus 1/8 equals, we keep the denominator the same, we subtract the numerator. 3 over 8. Now number 6, we have negative 2 minus 3 over 4. When we're using negative numbers, you can look at it just like it is seen underneath. If both numbers, if the first number is a negative, then you're actually going to add the negative numbers together. Negative 2 plus negative 3 over 4 will give you negative 2 and 3/4. Because if you did negative 2 plus 3/4, when you do negative 2 plus 3/4, that is when you would actually be subtracting from this negative number and making it a smaller number. So this would be negative 1 and 1/4. But for this problem, we have a negative 2 minus 3/4. Negative 2 stays the same, and it is plus parentheses of negative 3 over 4, and it becomes negative 2 and 3/4. Okay. Should we do a couple? Okay. Let's look at a couple of these. Number 1, let's look at number 1. Now for this one, we have 7 over 11 plus negative 5 over 11. If we are adding a positive number, which 7 over 11 is, with a negative number, it becomes a subtraction problem. 7 over 11 minus 5 over 11. We keep the denominator the same, subtract the numerators. We have 2 over 11. However, if we're looking at number 6, when we are subtracting a negative number from a number, we have negative 3/5 minus 1/7. We look just like what we had on this example on number 6. And it becomes an addition of negative numbers. So negative 3/5 plus negative 1/7. We have to find the least common denominator of 5 and 7. The least common denominator for this would be 35. 5 times 7 is 35, and 7 times 5 is 35. So we have negative 21 over 35 plus negative, we're going to have to do this underneath, plus negative 21 over 35. I'm sorry, 5. The numerator is 1. Multiply it by 5. We have 5. So we have minus 5 over 35. Now when we have negative 21 plus negative 5, that becomes negative 21 minus 5, which is the equivalent of negative 21 plus 5, negative 26 over 35. Okay, well, that was the answer to that one. Okay. Well, thank you for listening. And if you want to do these at home, you're more than welcome to. Okay. Oh, really? Yeah, that pen, it was like in my hand, and then I heard the